So what we'll be doing is the first thing we have to do is we have to basically set up our direction finder. Now it says basically Bob leaves the house 1.2 kilometers to the east and then 0.6 kilometers to the north. So we draw our first vector, 1.2 kilometers to the east. Then we draw our second vector, north. I always have my reference cross there as well. I put 0.6 kilometers north. Now the resultant vector goes from the starting value all the way to the ending value. And that is our resultant vector. Now, let's compute the magnitude of the actual length. Because this is a right triangle, we're immediately going to calculate r using Pythagoras Rule. So, we have the magnitude of r squared is equal to 1.2 squared plus 0.6 squared. Going to the next line, we have 1.44 squared. Oh, I made a mistake. Got to remove the squared. It's already squared. Plus 0.36. Now, adding those together, you get 1.8. So the magnitude of r squared is actually 1.8. Now we'll just take the square root of both sides to get the magnitude of r to be equal to 1.3. Kilometers. Now, the next thing we have to do is we have to find a relative angle. Now let's see. Let's use the angle that's formed with the blue vector we have here and r. We'll call that theta. So we'll use tangent to do our calculation right away. Tan of theta is equal to 0.6 over 1.2. Going through the motions, we find that theta is approximately, just doing this on my calculator, 27 degrees. And now we have to create our final statement. Now, we're just trying to find the final position, so we're going to say the final position is 1.3 kilometers east, 27 north, or we could have said north 53 degrees east. Now, the next problem is basically just adding vectors, so we'll go and do that now. When we add vectors, we need to think about placing them head to tail. Just adding vectors always is just adding head to tail. Some of us say tip to tail. It doesn't really matter. Just make sure that no two heads or no two tails are touching when you are doing the, well, addition of two vectors. Now remember, it is head to tail. And here we go. If we take a look at a plus b, basically what we're doing is we're going to actually copy the vector a and we'll place it. Then we have to copy the vector b and then place vector B's ending place vector A's ending where vector B's start is, like so. And then our resultant vector ends up being the red vector we see here. It starts from the beginning of A and goes to the end of B. And we call that the vector A plus B. Now, let's continue. We have B plus A plus C. In order to do all those three, we actually have to copy B, place it. We're going to copy C exactly as you see it, but put it on the end of B. So we're taking A and putting it on the end of B. Here we go. It's a little difficult for me to do this on the computer. If it was my pen, I would use a ruler and a protractor to get the exact vectors. And then finally, we're going to tack on C to the end of A. And here we go. Now, even though we have three vectors, we always start at the beginning of the path, which was the beginning of B, and we go all the way to the end of C. And that resultant vector is B plus C, A plus C. And what's interesting is, if I had done it A plus B plus C, the vector, the resultant vector, would still be the same. It's amazing how this algebra works. Now for B plus A, we start with B, and then we take A and we tack it onto the end of B. And you'll notice the vector is exactly the same. Take a look at that. Draw the resultant vector, and you'll notice that the resultant vector for the A plus B is the same as B plus A. So it doesn't really matter which order you do the addition. It's actually commutative. That's what we call it. Now, let's do the last one, B plus C plus A. Let's see if it gives us the same looking vector. So there's B. Let's take a look at C. Let's move C down. And now we've got that on. And now let's take a look at A. And then B plus C plus A gives us this vector. So copy the A down, and I think we end up having the exact same thing. So basically you need to realize that if we have these vectors and we're adding them, it doesn't matter which order we add them, the resultant red vector will always be the same. I could have done ABC or BCA or BAC or CBA, and all six different permutations of A, B, and C would give me the exact same resultant vector. Your homework will be the following: number 4, number 6, number 8, and number 2 for the adding vectors section.